All right, so you're looking at June 2006, paper 1 Chem. Let's start. Sulfur and oxygen are in the same group of the periodic table because why would they be in the same group? Elements in the same group have the same number of what? Correct. C. They have the same number of electrons on the outer shell. Right. Right. So for this one, we're gonna get C here. Right. Same number of electrons on the outer shell. Very good. 2. If atom X forms an ion, the charge on the ion would most likely be. So we need to look at the number of electrons on the outer shell. How many electrons are there? 1, 2, 3, 4. Seeing 2 and 3, 5 electrons on the outer shell. What would be the charge? Would it be easier for it to lose 5 electrons or gain 3 electrons? Right, so which is easier, right? Because losing and gaining electrons involves exchange of energy. So just like anything else in nature, choose the part with least resistance. Here it would gain 3. If it gains 3 though, then you'll end up with 15 protons and 18 electrons, negative. So what we're gonna have an overall charge of, yep, that's right, D, minus 3. Right, very good. Yeah, everybody okay with that? Number 3, which of the following oxides does not react with acids to form only a salt and water? Yes, manganese oxide, that's correct. Right, all the other oxides would give us a salt and water. This one is a bit different, and it's because of the oxidation state of the manganese. Yeah. All right. So moving on up. Let's see. Looking at number 4. Right, for number 4, which of the following statements about covalent compounds are true? Covalent compounds. Right. So see, we have 2 and 3. Yes, I would agree with that because anything with 4 is out. So automatically B and D is out. And they're not mainly solids. I mean, methane is a covalent compound, right? There are plenty of other covalent compounds, and some of them are liquids and gases. So one is incorrect either. So C is right. They generally have low melting and boiling points in comparison to the ionic compounds, and most of the time they're insoluble in water. Right, so good answer. 2 and 3, very good. 5, which of the following statements illustrates osmosis? Right, movement of water molecules across a cellophane membrane into a concentrated glucose solution. Yep, that's correct, Navin. Right, Osmosis usually involves the movement of the water molecules through a semi-permeable membrane. So any answer along those lines would be correct, right? The cellophane membrane would be like that membrane that we're talking about. 6 radioactive isotopes are not normally used in the correct answer is C, treatment of influenza. Right? We use it in the treatment of cancer. They use that. There's an iodine type isotope that they use for people that develop thyroid glands. Then they usually use the barium salts when you're gonna do um, X-rays or you're treating cancer cells. Determination of or the age of fossils as carbon dating, powering certain types of submarine. We're talking plutonium type stuff, nuclear power we're talking about there, right? 7. PO4 3 minus is the formula of the phosphate anion. What is the formula of the calcium? What is the formula of calcium phosphate? Right, an easy way to do this when you have to come up with your formula is the cross method. So once you know the charge on each of the individual ions, you can cross it like that, right? In the case of the PO4, you just put that in a bracket. This becomes a 2 and we get a CH3. So the correct answer here is A. Everybody all right with that one? 8. From which of the following can a solid be obtained by the process of sedimentation? Yep, that's the suspension. Right, you allow it to settle and you get the sediments at the bottom. Very good. 9. In the reaction between zinc and dilute sulfuric acid, what happens? Metal and an acid. What happens when you react a metal and an acid? You get salt and water only. Correct, water is formed. Yeah? Very good. 10. Which of the following elements exhibit allotrophy? Right? Same. Yep, carbon. What are the allotropes of carbon? You have two allotropes. One is very expensive and one has a good lubricant, right? Graphite and diamond. Very good. 11. Which of the following may be defined as the quantity of substance which contains 6.02 by 10 to the 23 particles? This is an easy one. Yep, mole. This is the easiest mole question you'll ever see. Right? B is correct for this one. Very good. 12. The values of x and y, respectively, in the equation are, we're going to balance this. Any ideas? What do you have in mind? Yep, correct, Jadon. B, 6 and 5. Right, good job, excellent. Moving back up to the top, number 13, how many covalent bonds are there in a nitrogen molecule? Right, Naveen has 3. Any other answers? Anybody else? We're quiet this evening. 3 is correct, right? And you can tell by the oxidation state, right, or the charge, right? Nitrogen has a 3 minus charge, right? Nitrogen is also in the same period as oxygen, as in a group 5, so it needs 3 electrons to complete that outer shell. Yeah? You think about NH3, ammonia molecule, right? 3 covalent bonds there. 14, a separating funnel can be used to separate a mixture of separating funnel. Yep, that's correct. Water and kerosene, oil and water. 15, a substance X with a boiling point of 58 degrees is miscible with another liquid Y of boiling point 94 degrees. A mixture of these liquids can best be separated into its components by fractional distillation. I don't know, I find it relatively, it's far, it's not very close. So I mean, simple distillation I think should work for this. You know, you usually do the fractional if they're close. But 58 degrees is a far cry. Yeah, 58 degrees is a far cry for 94, man. By the time you get to 58 degrees, X would already start to evaporate. Right? So as that starts to evaporate there, you can kind of maintain your temperature around there, and you would be able to get that out, right? Run through the cooling chamber. So I think I'll go with E for this one. Fractional distillation, sorry, not A, my bad. With B, simple distillation. Fractional distillation, you want them with very close boiling points. You want 10 degrees difference. 16. Let me just make sure that actually, yes, leave it as a fractional distillation. Leave it as it. Right? Different boiling points, and they're miscible, so they can mix together, meaning that you wouldn't be able to distill one from the other. So fractional distillation is correct, right? So you go with E for this one, fractional distillation. Right? 16, which of the following gases is composed of molecules containing 2 atoms each? Two atoms. Yeah, correct. Very good. Right, hydrogen chloride. This is 3, this is 4, and this is 5. So this has 2 atoms, hydrogen and chlorine, and that's ionic bonding. Carbon dioxide, you're talking about covalent bonding, and you're looking at three molecules. Ammonia, well, I draw ammonia for you just now, NH3, right? Methane, sorry, I was drawing methane here, it should not be. Methane looks like this, so five molecules. Right, very good. About at all. 17. So a compound when treated with concentrated hydrochloric acid gives off a green gas which bleaches red litmus paper, right? Now, always bear in mind that red litmus paper is for testing for alkaline stuff, right? And here we're treating something with hydrochloric acid. Which gas do we test for? Yep. Bleaches the moisture litmus. This here gives it is the key. This gives it away, right? Because it bleaches the moisture litmus. That's how we know it's chlorine. Very good, Navin. And it's green gas, correct? Right? And chlorine has that yellow-green gas. Is chlorine, right? Remember that, guys? Chlorine is a yellow-green gas. You have a choking scent. Right? Bleaches moist red litmus paper. Mm. 18. In which of the following substances? Yeah, for real, right? Yeah, chlorine gas is very toxic. They used to use that in water. That's how they used to purify the water. They used to have these huge gas cylinders, and they used to I had a friend who used to work on one of the water treatment plants in Falsing Waterworks. Used to go there, and they had these big tanks that they would use to inject gas into chlorine gas into the water. That's what they used to purify. It was costly and it was very hazardous. And with the event of HSC stuff and the OSHA Act and stuff, WASA eventually started moving away from using the chlorine gas. And what they use now actually is UV light. You could use UV light to get rid of bacteria and stuff. I think even like right now they have stuff on sale. With the whole COVID and everything, and there's the UV light that I could use to sanitize your phone and door handles and stuff like that. Like UV light does a good job. 18. In which of the following substances will electrolysis not occur when electrical current is passed through it? Not occur. So it means that there are no free ions or electrons available. That's right. C, solid sodium chloride. And always remember, sodium chloride is table salt. Right? If you remember that, some of these things are kind of, it's easy to figure it out because you'll be like, electricity not going to pass through the jar of salt in the kitchen. Right? 19. Sulfuric acid is a stronger acid than ethanoic acid. Is that in aqueous solution? I think so. Because sulfuric acid is what? Why is sulfuric acid stronger? What makes it sulfuric acid? I think I already explained this before. Yeah, B. It ionizes to a greater extent ethanol. Remember when I was showing you that? And I was telling you basically when it ionizes, you have two hydrogen ions, right? In comparison to when acetic acid ionizes. It doesn't fully ionize to begin with, right? And then you have one hydrogen ion. Yeah. 20. Barium is below calcium in group 2 of the periodic table. When these metals react with water, the main difference in observation will be the rate of reaction and what else? This one is a repeat. You would have seen this one before. What's the other main difference? Barium, calcium, same group. What happens with the reactivity in the group as you move down the group? Yes, correct. Very good. Well done, Jadon. Solubility of the product. Excellent. Right? That's the other thing that will be affected. Because the more reactive it is, the more soluble it will be. Yeah? Very good. 20. Let's go up to 21. In which formula does hydrogen have a negative oxidation number? Negative. This is another repeat. You've seen this one before. Negative oxidation. Very good. Well done, Navin. Well done, Shivana. Excellent. D. I have a negative oxidation number there. Right? 22. The bulb will light the most brightly when X is what? A sugar solution, distilled water, aqueous ethanoic acid, dilute sulfuric acid. Yeah, the one that ionizes the most. Well done, guys. Excellent. D. 23. Two solutions are mixed in order to demonstrate endothermic changes. Which of the following techniques will be most appropriate? Right? Anytime we're talking energy changes, what we measure in there, guys? How do we measure energy changes? Changes of heat, temperature readings. Well done. Good job, Destiny. Jadon, Navin. Right? Temperature changes is what we'll be looking for. This one was a repeater as well. Good. 24. The reaction occurring at the cathode during the electrolysis of copper sulfate using inert electrodes. Right? So that means the electrodes not participating. Is given by the equation. Which one? So at the cathode, I always want you to think cathode going to have what coming to it? Cations. What are the cations that's going to be present in copper sulfate? So copper for sure is one. And well, if it's in solution, the other thing is a hydrogen. So which one is going to be liberated? The lower the ion is in electrochemical series, the more likely it is to be discharged from a solution. Let me say that again. Unlike the reactivity series, right? The electrochemical series, this is for electrolysis. The lower it is, right, the more likely it is to be discharged. So what are we going to be seeing? Right, very good. Good answers. B, right? Copper is going to be discharged, right? The electrochemical and reactivity series is more or less the same thing. It's just that you use different words when we're talking reactivity of metals from when he's talking about electrolysis. And then when we're talking reactivity of metals, the metal that is higher in the reactivity series will displace with another one that is lower. But when we're talking about preferential discharge, the lower it is inside of that electrochemical series, it's the same set of elements, we're just using different words to describe them. The lower it is in the electrochemical series, the more likely it is to be discharged. And copper is below hydrogen, right? So that's why B is your correct answer. Very good. 25. These two things are isotopes because of what? This is another question that is repeated. They have the same number of protons. Yep, you're correct. They kind of take a different route with this question, so pay attention to this. This is confusing most people because you're accustomed saying that isotopes, they're isotopes because they have different mass numbers, which is true. They do have different mass numbers, but they do have the same number of protons. That's also true. And see, now we didn't have anything talking about mass numbers here, right? Relative atomic mass is they don't have the same relative atomic mass. One is 24, one is 23, right? The correct answer will be C, same number of protons. 26. When solid lead nitrate is heated, it decomposes, giving off nitrogen 4 oxide and oxygen. The balance equation for this reaction is I'm going to balance it there for now. E, Navin says A, let's check. So 2 lead, yes, 2 lead would cancel here. We have 2 ends, so we end up with 4 ends on the side. There's 4 ends here, 4 ends there. What is this? Is this an NO3? Yes, it is. So that's 6 O's by another 2. That's 12 O's. And I am seeing here 4 2's are 8 and 2 10. I could be blind. Ah, look at the other two here. 12, right? Very good. Yeah, that's it. That's only lead, only lead, only nitrogen, and only oxygen. So two lead, 2 lead atoms, right? Cancel there. We have 4 N's, you cancel in that, and we have 6 by 2 is 12 O's on this side, and I have 2 O's here, and then I have 8 O's here, and then I have 2 more there. So 2 and 2 is 4, 4 and 8 is 12. A is correct, right? Usually I would write them out. So I would write that, then you remember you had to check these subscripts too, right? So this 2 multiplying by this n, and then you had to multiply by 2 there as well. So that's 4 n's, and then 2 by 3 is 6, and then by that 2, that's 12 O's. And then come on the next side and you do the same thing. 2 PB, right? You have 2 O's there, then you have 4 n's, then you have 8 O's, and then you have another 2 O's there. So that's how we know you cancel off, right? And you're good to go. Very good. 27. Which of the following halogens is a liquid at room temperature? This is another repeat. I gave you all the answer for this before. Liquid at room temperature. Tell me. Which one is a liquid? Yep, that's correct. Bromine. Bromine is a liquid at room temperature. Just tell you about chlorine is a gas that they was using at Wasser. 28. 28. A solution has a pH of 1. Right? This solution would be expected to do what? A, react with zinc metal to produce hydrogen. Yes, that's correct. Good answer. 29. Ionic bond formation is best described as a result of ionic. Any sharing taking place there? Yes, B. Donation of electrons, and that donation of electrons is it's coming from a metal and going to a non-metal. Think sodium chloride. Sodium is giving up an electron, chlorine is gaining it, and that's how you have the ionic bond taking place there. Very good. 30. During which section of the graph is the substance changing its state? C. 2 and 4. Yeah. Yeah. During that time, you have a mixture of two things. Yeah. Solid and liquid. Remember when I was showing you the graph for that last class? Remember that? 31, which when heat is given off to the surroundings during a chemical reaction, given off to the surroundings, it is because bond breaking does what? Remember I was telling you, enthalpy change right? Negative is exothermic. That means that the reactants have more heat energy than the products, right? So right, that'll be C. This needs more energy. So this is higher. If this is higher, you get overall negative delta H, the exothermic. Right? Heat given off to the environment as included exit, exothermic. Everybody right with that one? Make sense? 32. An excess of magnesium powder is added to 50 centimeters cube of dilute sulfuric acid. The reaction is allowed to continue until no more hydrogen evolves. Which of the following graphs best represents the complete reaction? This is another one we did too. Right, if you could have this type of repetition on an exam day, that would be good. What we said about this? D? Sure. So magnesium powder and sulfuric acid, you know you're gonna liberate hydrogen gas. But one is in excess and one is limited. Look at this. An excess of magnesium powder is added to 50 centimeters cube. So what happens when the 50 centimeters cube of sulfuric acid is all used up and there's no more of this? This is a limiting reagent. This is not in excess. This has a limit. There's only 50 centimeters cube of it. So when all of that is gone, what is going to happen? Is this reaction going to continue any further? Nope, it's not. So which graph would best represent a termination or end point for the overall reaction? E. Yeah, right? After a particular time, you're not going to have any more hydrogen gas being liberated. A perfect example is your soft drink. That's carbon dioxide gas that's coming out when you open it. And you go, shh, and it fizz. You shake it up again and you open it again. What's going to happen? You get less and less until eventually. Yeah. Now it wouldn't level off because leveling off means that you're still getting a particular volume of hydrogen gas being liberated. And that's not the case. Once all of this sulfuric acid is used up, Then the reaction stops. There's no more reaction. Yeah. Even B is the answer that I'm now looking at it. You know, as less and less of this becomes available, right? The reaction is gonna slow down. The volume of hydrogen being released is gonna eventually slow down, right? Stick with what we have. E. Say the 3, a lump of metals reacted with an acid to produce hydrogen gas. Which of the following procedures could be employed in order to increase the rate of reaction? How can we increase the rate of reaction? B, 1 and 2. Increasing the temperature, subdividing. That's correct. Reducing the concentration wouldn't help. Right, so that's a good answer. B, 1 and 2. 34. When 100 centimeters cubed of 2 molar hydrochloric acid, right, excess, added to 5.0 grams of granulated zinc, hydrogen is evolved at a certain rate. If 5 grams of powdered zinc were used instead, the rate of production of hydrogen would what? So we use from granulated to powder. Yep, another B. Increase because the surface area has now increased, right? So reaction will take place faster than before. 35. Which of the following aqueous solutions contains 1 mole of hydrogen ions? One mole of hydrogen ions. Well done, Shadon. D. Very good. Right? 2 dm cubed are 0.5 moles per dm cube. This means for every dm cube, for every 1 dm cube, right, you're going to get 0.5 moles. Right? And we have 2 here. Right? And if you notice here, you have 1 H, which is here. You're talking about hydrogen ions. Yeah, so in solution, you'd liberate just 1 mole of your hydrogen ions here. 24. Ethanol can react with concentrated sulfuric acid to produce ethene. The reaction is referred to as yes. Right? Don't confuse it with whatever that they have for C, right? I don't even know if that's a real thing. Right. So dehydration, we have that. Moving forward now, 36, 37. Sorry, 37 was at the bottom here. Which of the following equations represent a condensation reaction? Now, condensation reaction usually involves loss of a small molecule, usually water. A, CN Look like ethanol. Yep, A is correct. Why not? I just out of curiosity, right? Why not D? Why D is not the answer? D is an example of what? So let's call this. It's not a condensation reaction. There's another name for it. It starts with N. Any ideas? Neutralization, that's correct. Right, so A is condensation, D is neutralization. 38. Which of the following compounds is not a member of the alkene series? Not a member of the alkene series. Right, alkenes should have the H2N. Right, so whatever is the number on the A on the K for carbon, the H should have twice that amount. So check it and tell me which one. I can't see too good. Yeah, I think C looks good. Because I see in C2H6, right? If N is 2, then 2N should be 4. Yep, very good. Well done, Destiny, Navin, Jaden, all good answers. Yeah. 39. Octane, the major component of gasoline, is an alkane with 8 carbon atoms per molecule. Which of the following is a formula for octane? Right, alkenes now, the general formula for that is a bit different. 2N plus 2. So if you have 8, what are we going to get here? D? Yes, D is correct. D, right? Good job. 40. The compound ethene is described as being unsaturated. This means what? Yeah, unsaturated means that it contains at least one double bond. 41. What is the product if I take ethene and I use water and concentrated sulfuric acid? What are we trying to go to? Product 1 is, remember we went from alcohol to alkene just now and they said it was dehydration. This one is hydration. So what's the answer? Ethanol. That's what we move into, ethanol. Yeah? Everybody okay with that one? It's the opposite of we saw with the dehydration earlier. Drop a one if you're okay with it. You're quiet today, boy. Well, at exams today or what? The number of isomers of butane is. This is another one we saw recently. Let me draw it out. 2. B. Yeah, correct. Very good. 43. Match the following. Decolorizes bromine water. What's decolorized bromine water? Alkane or alkene? Alkenes give you rapid decolorization of your halides. Right, so I will go with P, cyclohexene. Very good, Destiny. Well done, Navin. Is an unsaturated carbon. Again, gonna go with cyclohexene, right? Because it's an alkene. Let's look for the enes. Right? Ethanol may be used as a fuel because why? Why can we use ethanol as a fuel? Fuels need to have what? A high heat of combustion. Think about petrol. That's why it can't smoke, or it can't go around gas with naked flames. It has a high heat of combustion. I mean, you don't even need to be too close. The vapors themselves can ignite. Glucose is converted to starch or cellulose by, there's two types of polymerization. There's addition polymerization, and only alkenes is go through addition polymerization, right? That's the only one that has to addition polymerization. Everybody else does condensation polymerization, right? So your starch or your cellulose, when they have to do the taking amino acids to make proteins, when we're talking synthetic polymers like terylene, polyethylene, not polyethylene, sorry, nylon. Polyethylene is addition polymer. 47. The following represents a portion of a nylon molecule, polyamide. Funny, just talk about it. The linkage could best be represented by, so looking for amide linkage. You're familiar with what the amide linkage looks like? Any answers? C? Yes, Navin. C is for this question is correct. This is what your polyamide linkage. Wait, just one sec. Oh no, wait, I'm missing something. This is not it. Polyamide linkage, you're looking for a C double bond O and an N and an H. Tell me if you see 9 here. Okay, yeah. Yeah, oh, sorry. That was the last one. This is it. Very good. 48. Which of the following substances give a blue coloration with iodine? Me bio student say, how do we test for starch? We use iodine and what happened? Bio people. Right? Blue black color presents as starch. 49. Hydrocarbons are obtained naturally from, where do we get hydrocarbons from? Petroleum. Right? Petroleum. Good. Um, during manufacture, during manufacture of ethanol by fermentation, the gas evolved. Will be what? Which one is this? A, D, or you mean the petroleum? Yeah. Yeah, none of the others make sense. The gas evolved as carbon dioxide gas as a byproduct, and carbon dioxide gas turns lime water cloudy because the carbonate in there, you get the calcium hydroxide, milky white. 51. The reaction of fats with concentrated aqueous sodium hydroxide is commonly referred to as not neutralization, not condensation. Yep, very good, Jadon Navin. This is 51, saponification. Right, that's how we make soap. Very good. 52. During the digestion of polysaccharide by the human body, the main process occurring is yes, condensation. Wait, 52. Still written. Digestion of polysaccharide by the human body. Main process by people. Condensation. We're breaking up the polymer. We're breaking it up. We call it what? We have acid hydrolysis and alkaline. Hydrolysis is where you break up the. Yep. Because you're breaking it back up. Because remember when you're digesting the polysaccharide, you're trying to get back to the monomer unit. Yeah? So that's hydrolysis taking place there. Yeah? 53. Which of the following may be true of metals? Which of the following is true of metals? B. 1 and 2. Form solid chlorides are they generally form basic oxides. Yep, that's correct. Right, so we know 3 is wrong. That don't make sense. Yeah. They conduct electricity only when molten metals. Yes, metals, not the salts. Right, 54. What is observed when excess aqueous ammonia is added to a solution of copper 2 sulfate? I did this. Let me send it to you. I want to send it to you. I wanted to add some more things to it before sending it to you. But as I see this question, I go down and send it to you now. If I didn't send it already, again, all in I forget. Where the thing go now? What are we using there? B. Deep blue solution. Yeah, and why is that? What is causing it to give you that deep blue solution? What ion gives that color? And why they use ammonia? Is it that ammonia use ammonia to look for anions or cations? Right, that's correct, Navin. That's copper gives that blue color. And that's how you have to look at your things, right? You need to start thinking about, well, what do you use to test for cations, right? And anytime you see they add in something like sodium hydroxide, or they're talking about ammonia solution, There's two main tests to determine cations, right? Did I send it in the group yet? No, I didn't. Send to what the hell happened there? I just sent it. I wanted to add some more stuff to it, right? Because that note that I had there was from some time before, and it have some other things that not included there that I wanted to include for you guys before I send it. But you can work with that in the meantime. That has some of the tests for your anions and cations, also your identification of gases, and it's not too cumbersome. It's summarized nicely, so it's easy for you to just learn off. Right? So I was telling you that there are two types of tests, right? There are tests for cations, and the tests for cations usually involve the addition of sodium hydroxide, right? Or ammonia solution. Right, so this is cations. Anions, what do we use to test for anions? Anybody knows? Common, we have silver nitrate followed by silver nitrate followed by aqueous ammonia. There's also barium nitrate or barium chloride. Followed by each of these, if you use any barium chloride, you have to use HCl with it. If you use any barium nitrate, you have to use nitric acid with it. Right? That's just always good. I'll explain now when we're looking at our other handle. But these are the common ones. So you can look out for these anytime you see that happening. You know whether right. You're looking for cations or you're looking for anions. 55. The role of the catalyst in this reaction is to do what? You see nitrogen gas, hydrogen gas, they're trying to make ammonia. Why do we use a catalyst? Any ideas? Increase the rate of production of ammonia. Yep. Right, it increases the rate of production of ammonia by giving it an alternative path. Right? 56, the notation delta H is equal to minus 92 kilojoules per mole means what? What does this mean? Any of the ladies? Only in Destiny. Rest of you all tonight. Everybody tired? A 92 kilojoules of energy are required for the reaction to proceed. Well, this is an exothermic reaction, right? This time your specific heat capacity, energy change. Basically what it's saying is that 92 kilojoules of energy is released during the reaction. Yeah? Good. 57. Which of the following substances may be responsible for acid rain? Who's the culprits for acid rain? Very good. Sulfur dioxide, hydrogen sulfide. Very good, Jidan. Well done, Navin. 58. Which of the following processes gives a different gaseous product from the others? Photosynthesis in plant. You saw this already. This gives out what? Oxygen. Respiration in animals, carbon dioxide. Oxidation of carbon monoxide is the addition of oxygen. Heating of calcium carbonate, calcium dioxide. Yep. Photosynthesis of plants. Right? 59. Aluminum is obtained industrially by? You know it's electrolysis of what? C. Molten cryolite. Yep. It's more the cryolite is not the cryolite is where it's added, right, to help lower the temperature. So it's not really the cryolite that I do electrolysis of, but really the yeah. So you had to add this to here, and that's lower the temperature at which it would melt at. Right, so it's a combination of the two. It's really use bauxite. Bauxite is impure aluminum. So they probably try to play with it here a little bit. Okay. 60. Both glass and ceramics contain non-metal. What? Both glass and ceramics contain the non-metal what? You know always make glass? Huh? Yeah, silicon. That's correct. Very good. Very good. Right. All right, next one. Sand contains, yeah, you see the sand. A semi-metal. Kind of. Is it one of them transition metals, is it? Silicon. No, actually silicon is a group 4 element right underneath carbon. So it's a non-metal. Yeah, it's right underneath carbon. So I mean it's the same, you're gonna have the same type of behavior as carbon will have. Remember it had that question with the carbon, and it was saying that carbon is bond with hydrogen, and what you would get if you use silicon instead. Remember that question? It's the same thing, they're in the same group. So they would have the same type of chemical properties. Yeah? Alright, good. You want to look at the other paper next? June 2003. It's not the prettiest of paper where you make it work. I'm just going to pause your recording just for 2 minutes. You guys just need to use the bathroom or anything like that. I could use that quickly. And we try and finish this paper tonight, right? So we might go over the 7 bar a little bit. But we try to wrap up this one fast. So just a quick 2-minute break. Resume recording. Sorry about that. So this is June 2003 now, right? First one, which of the following apparatus instruments most suitable for obtaining cooking oil and water from a mixture of the two? Separating funnel, you all know this one. 2. Which of the following statements are true about the arrangement of electrons, protons, and neutrons in an atom? Protons and neutrons are found in the nucleus. Yes. Electrons can be found anywhere outside the nucleus. Yes. Number of protons always equals the number of neutrons. Nope. Number of protons always equal the number of electrons. Well, in an atom, yes. Right? But let's see what they have here. So we need something with a 1. And is there a 2 anywhere? A 1 and a 2? There's no 1 and 2. So 1 and 4. Right? Anything with 3 is out. Right? So these sometimes do the elimination. Right? Anything with 3 is out. B is correct. 1 and 4. Yeah, 2 correct though, but I don't have any answers with 2 in it. Unfortunately, I was looking for an answer with 2 in it. When I say 2 and another correct answer, right? 3 is not correct, so anything with 3 is out. Yeah? You okay with that, right? Everybody all right with that one? Right? 3. Which of the following compounds may be conveniently prepared by precipitation? Precipitation. What are we looking for? We're looking for insoluble salts. Right? Anytime you're doing preparation of insoluble salts, you use ionic precipitation. Basically, you have two solutions, one providing the cations and one providing the anions. When you mix the solution, you have a precipitate that's formed, precipitate meaning that's insoluble, and then you could filter to separate the precipitate, wash out the precipitate with distilled water, dry it, and that's how you're gonna be able to get your salt. So you're looking for insoluble salt. So our sulfates are all soluble with the exception of lead and barium sulfate. So Navin is correct. A, barium sulfate is an insoluble salt. Right? Insoluble. Sodium soluble, copper sulfate, we know that. Magnesium nitrates, all the nitrates are soluble. Right? So A is the correct answer. 4. Which of the atoms represented below by the electronic configuration will most readily form a positive ion? So who's going to lose an electron easily to form a positive ion? Yep, that's correct. A, 2, 8, and 1. Very good. 5, let's see what 5 has. 5, in descending group 7 of the periodic table, which two of the following trends occur? We're going down group 7. So we're talking about the halogens. Density of the elements increases. That is possible. The relative atomic mass of its element decreases. That will make sense. The melting point of the elements increase. The reactivity of the elements increase. A says 1 and 3. Yeah, that makes the most sense. Because the more reactive ones are to the top. Right? The more reactive is to the top, least reactive to the bottom. Reactivity decreases as you go down that group. So not 4. Right? Very good. Good answer. Density increases. You remember we was asking about which one is a liquid at room temperature, and it was bromine. And the melting point of the elements would increase. Well, obviously the density increasing. 6. 6 says dilute sulfuric acid is classified as a strong acid because A, produces 2 moles of hydrogen ions per 1 mole of acid. I showed you guys that a short while ago. When this dissociates, we're going to get 2 moles of this, right? 1 mole of this. For every 1 mole of acid, you get 2 moles of hydrogen ions. That's what makes it a strong acid. 7. When a saturated solution of copper 2 sulfate is cooled, crystals of copper 2 sulfate 5 water begin to form because solubility of copper 2 sulfate 5 water, what? Increases with decreasing temperature, decreases with increasing temperature, decreases with decreasing temperature, increases with increasing temperature. Nice real words. So saturated. So take out the words that have the most meaning, right? Saturated solution. A saturated solution means that you have a lot of solute being dissolved in the solvent, right? Remember we saw the supersaturated one there, I was explaining that here. Right, so the saturated solution of copper 2 sulfate means I have a lot of copper 2 sulfate crystals in there. As it cools now, the crystals of the copper 2 sulfate 5 water begin to form because of the solubility of the copper 2 sulfate 5 water. What's happening though? The solubility is decreasing because in order for you to get crystals, right, another word that I want to pull out, in order for you to get the crystals of that, right, the crystals will only form if it's no longer soluble, right? You'd see the crystals at the bottom. So the solubility seems to be decreasing as, and they say here that it's cooled. Look at what it's saying here. It is cooled. So as it cools, you get more crystals. So to get more crystals mean that solubility itself, right? Solubility is decreasing while the temperature is also what? Decreasing. So correct answer is C. Yeah, makes sense? Yeah, just take your time with them. 8. The arrangement of elements in the periodic table is based on, what we arrange them on? Based on atomic number. Right? Remember I was telling you, write out your stuff, H, He, Li, and write the atomic number, increase in atomic number. 9. Iron trisulfate reacts with aqueous potassium iodide. A brown coloration of iodine is produced. Which of the following deductions is correct? So just note, right? Potassium iodide. Iodide here is an ion, is an anion here, right? It has a minus charge because there's more electrons than protons. And then we get this brown coloring of iodine produced. So you now go on to I2. So this goes to 0, right? So for the oxidation state to go from minus to 0, right, it has to lose electrons, right? Just bear that in mind. Oxidation is loss. Whatever is oxidized is a reducing agent. Now we can look at the answers. Iron trisulfate is a reducing agent. The iodine ion I has been oxidized to iodine. That makes sense. C, the ion trisulfate has lost electrons. The iodine ion I has gained electrons. So my best answer here, based on what I just told you here, would be B. The iodine ion, this ion here, has been oxidized. Oxidation is loss of electrons to become oxidation status 0. Ten. Which of the following statements about sodium metal are correct? Yeah, I know. It's a crappy copy of the paper. I don't know what happened with the Google Drive folder that I had access to. I think the person take it down boy, and I thought I downloaded it. There was another one I had without multiple choice. And I kind of I find this there somewhere on the internet. So because it was so old now, I say let's take a look at it because we haven't looked at this before. Chances are they could probably bring something from here. So apologies for that. We will make it work though. Sodium. Sodium ion. It contains sodium ion and mobile electrons. Okay, yeah, that's true. Contains cations which repel each other. That makes sense. It contains anions which repel each other. All right, so we'll forget that one. Forget that one moving forward. 11. when aqueous silver nitrate, I just tell you about that, right? When you're using silver nitrate, it's because you're looking for what? Anion or cation? Anions, very good, right? And most of those anions give this white precipitate. So it's either white, cream, or pale yellow. Or is this thing to remember it? You could say white cream or butter. That's how I used to remember the yellow, right? Um, the aqueous silver nitrate is added to aqueous solution of magnesium chloride. A white precipitate forms. The ionic equation for the formation of this precipitate is, yeah, looking for AgCl. So correct answer here is D. Right, that white precipitate is silver chloride. Right, and silver has a charge of plus, chloride has a charge of minus. So this is the correct thing here. Yeah. 12. In which two of the following equations are the underlying reagents acting as oxidizing agents? Oxidizing agents mean that they are gaining electrons. I can't really tell which one's underlying. Yeah, this is a very horrible copy. I didn't realize it's so bad coming down to the end. So here what we do. We do something else. We will do this. Let's go and check the website that I sent to you guys. So check this out. Find somewhere else to look at. People unbearable. We're not here now. CXCs wanna take down these things, these sites when they have the past papers up on stuff. They say copyright infringement. I'm sure the guy just take it off his Google Drive. He probably unshare it. I don't know how come I didn't. I thought I saved the entire file, and when I went looking for it, I couldn't get no boy. Okay, check. Got Jan 17, people 1 at June. We do June already. June 17, June that 14, we do that already. We do 16 already, as I say. June 11, people 1. Yeah, I think we do that too, right? I don't know. To me, I thought we reached 2009. Let's see what's going on with this paper. Pop out. So where is this now? Right. You press. Yeah, we do this already. Which of the following phrases illustrates diffusion? Perfume sent through the air in a room, random motion of pollen dust, swelling a red bean soaked in water, loss of heat from a hot body to a cold body. A. Nice. 2. The particle X is an atom of, you have protons, electrons, neutrons. 8 protons and 8 electrons. I think that is oxygen. Yep, oxygen. C. Right? You could look at the number of protons, sometimes electrons. Yeah? 3. Which of the following particles represent an anion? An anion, you have to have more electrons than protons. So where we have more electrons than protons? Here. Right? Y. So that's D is the answer for that one. Right, this is June 2011. Which of the following pairs are isotopes? Isotopes have the same number of protons but different number of neutrons. They have different mass numbers. So V and X. V and X. C. Right, good. 5. Which of the following ions require the largest number of moles of electrons to liberate 1 mole of it? Right? 1 mole of it. Largest number of moles of electrons. Aluminum. You gotta get 3 electrons. Right? Think about when you're doing the electrolysis. The atomic number of element Z is 13. Right? This is why I need to be able to do this. Right? In the which group of the periodic table should this element Z be placed? Group 3. B. Right? Write the electronic configuration of and the amount of electrons in the last shell tells you the group that's going to go in. The oxidation state of element Z would most likely be, well, if it's 3 on the outer shell, it will be positive 3, right? Like our transition method. Because 13 would give 2, 8, 3. Oxidation state when it loses these 2 electrons, with positive 3. Nice. Which of the following mixtures can be referred to as a standard solution? Not A, not B, not C, D. This is a standard solution. It's a particular mass in a particular volume. Very good. 9 now. We just saw this, when solid lead nitrate is heated, it decomposes, giving off nitrogen for oxide and oxygen. The balance equation for this reaction is, I've only did this one recently, A. 10. Which of the following compounds has the greatest percentage by mass of carbon present in 1 mole? These are the MRs, right? And we're looking for the one that has the most amount of carbon. Here we have 6 carbons, so 6 12s are 72 out of 180. 2 carbons, so this is what, 24. Out of 46. 36 out of 60 for B. And A is 24 out of 60. So which one? I think it's C. 24 divided by 46. That's 0.52, 52%. 66 divided by 60. 60% for B. 40% for D. 40% for A. Correct answer is B. Right? How did I calculate that? 36 over 60 multiplied by 100. That's more than 50%. Half of 60 is 30. So 60%. Yeah? B is the correct answer. 11. A metallic bond is formed when metal cations are held together by a sea of mobile electrons. That's how we get metallic bonding. 12. An example of a substance with a macromolecular structure. Macromolecular. So this one, what we get? This is simple. This is metallic. Ethyl and ethyl. This is probably more simple covalent. Starch to give us a macromolecular structure. Right? It's like a polymer. This is a polymer. 13. Which of the following is correct formula for ammonium carbonate? Right? Remember that table? We saw this already. It's actually C. Because ammonia is +1. Right? 14. Graphite is used as an electrode because doesn't burn, has mobile electrons. It's a metal, it's a reducing agent. Why? I guess it's A, because it doesn't burn. Mobile electrons have nothing to do with it. Graphite is not really a metal, it's an allotropic carbon. And reducing agents has nothing to do with it. But remember, we had to put this thing, is like, what was the temperature? We had to heat aluminum to put it inside of a through electrolysis. It's ridiculous temperatures, so this has to be the most suitable answer. It doesn't burn. 15. Which of the following statements about covalent compounds are true? Just saw this recently, man. Mainly solids. That's not true. They usually have low melting and boiling points. Yes. They are insoluble in water. Yes. 2 and 3. C. Yeah. 16. A piece of calcium was added to some distilled water in a container. The gas produced would be expected to give a pop with a lighted spin. Remember, when you add calcium to water, you're going to get a metal oxide and hydrogen gas being liberated. Right? Give a pop with a lighted spin. 17. A separating funnel can be used to separate a mixture of water and kerosene. We saw this already too. 18. One way in which hydrogen resembles group 7 elements is that hydrogen So a colorless gas like halogens is 1 electron short of a rare gas structure. That's actually true. Donates electrons very easily to form H plus ions. That's not true. Has its atoms held together by electrovalent bonds. B. 19. The pH of fresh sugarcane juice, which is usually in the range 5 to 5.5, can be changed to 7.5 to 8 for more efficient processing by adding what? C. Slaked lime, calcium hydroxide. And you can put limestone in the people sugar, right? Slaked lime, calcium hydroxide, or lime water. 20. Sulfuric acid is a stronger acid than ethanoic acid in solution because the sulfuric acid ionizes to a greater extent than ethanoic acid. 21. Which of the following is not a normal salt? Right, the only odd one out there is D. This is an example of an acid salt. And I can say this because of the presence of that H there. The ionic equation for the reaction between an acid and a carbonate, well, I know I have to get carbon dioxide and water. I need 2 hydrogens in order to do this. So C is my correct answer there. 23. Which of the compounds is reduced? All right, so let's see. Sulfur here, we needed 2 oxygens. So this has to be positive 4 here. And now you need 3 oxygens. So this is positive 6. Reduce is the gaining of electrons. It didn't gain electrons because the oxidation state increased. Let's check nitrogen. This one here is plus 4. This one here is plus 2. This one gained electrons. Which of the compounds is the oxidizing agent? So this already. Whatever is being reduced is the oxidizing agent. So answer for this one, A. 25. Acidified potassium manganate 7 is usually used as a reducing agent, oxidizing agent, both oxidizing and reducing. I want to say B here. I'm going to just check that before I move on. I think I might be wrong. So brain's getting old, I don't store all of these things in the head no more. I thought this one was doing oxidation reduction. Reducing agent. Acidified potassium manganate and acidified potassium dichromate are all reducing agents. Right? 26. Which of the following occurs to a metal atom when it becomes an ion? Loses electrons. Loses electrons and is oxidized. Nice. There we go. You're almost there. 27. In which of the following does hydrogen have a negative oxidation state So this a little while ago. NaH, right? 28. If the solution containing 1 mole of solid per dm cube of aqueous solution are investigated, which solution should cause the bulb to glow brightest? So this just now to sulfuric acid, right, to provide the most amount of ions. 29. Which of the following will not conduct electricity? Solid calcium chloride, right? No free ions or electrons to conduct the 30. A current of 5 amps was passed for 193 seconds through a solution of copper to sulfate using copper electrodes. The mass of copper that would be gained is, what will we get here? 5 amps right, and we gotta look at the equation. Copper 2 plus 2 electrons to give copper solid, right? So you need 2 Faradays to produce 1 mole, and here we're talking about 965 Faradays. Right? So 1 would produce 0.5, so 965 divided by 965 00 equals multiply by 0.05 B. Right? You have to use this equation here to figure out how much Faradays produce 1 mole of copper. Because it's 2 moles of electrons, 2 Faradays produces 1 mole of copper. So 1 Faraday will produce 0.5 moles of copper. Right? You need to now look at how much Faraday is actually passing through this circuit. 5 amps by 193 gives me 965 Faradays, right? Sorry, 965 coulombs, and I divide by 96,500 to convert that to Faradays. So 965 divided by 96,500 multiplied by 0.5, right? Because 1 Faraday gives me this. So this amount of Faraday by 0.5 will tell me how much. If I tell you 1 apple is $2, how much for 95 apples? You'll multiply 95 by 2. So it's the same thing. 1 Faraday is 0.5 moles. So this amount of Faraday by 0.5 is going to tell me the amount that's going to be deposited. Yeah? All right, guys. We wrap up with this for today. We got 13 in this paper. We'll finish up the other one.